try to solve Leetcode problem 292, Nim Game. So we are playing a game, and this n is just a value. For example, this is 4, and for each time, Alice and Bob can take steals from the pile, but it should be in the range of 1, 2, 3. Yeah, and also this number n is 2 to the power of 31. This means while we are considering the game theory DFS or DP, we need to consider if this n is too big. Yeah, how should we solve this kind of constraints if the n is too big? Yeah, let me first go to the whiteboard to explain the problem, and then go to the code editor to finish the coding. Yeah, so the problem is like this. So for the steals, as the example said, if there's only 1 steal, 2 steal, or 3 steal, yeah, so definitely I gonna win. Yeah, so it's gonna be a true and true and true. But if there are 4 steals, definitely I gonna lose. Yeah, because if there are 4 steals for each time, I can take 1, 2, or 3. So if I take 1, 3 left behind. If I take 2, 2 steals are left behind. If I take 3, 1 steals are left behind. It means next time Bob can always take that steal and Bob will win. So this means, yeah, if there are 4 steals, I will lose the game. Yeah. So from this, can we get some information from this? Yeah. So this means from this point, we need to check some previous state. So for this state, how can I get a win? If I were to win at this state, it means at some state before, if this state is n, yeah. So the state before is n minus 1, n minus 2, and n minus 3. Yeah. If either of them is a false, it means I can win because both A and B, both Alice and Bob plays optimally. Yeah. So this means inside 1, 2, 3, I need to find a false. So there's no false. So this means if this number is 4, it must be a false. Now let's go to n equal to 5. If n equals to 5, it means the 3 numbers before this 5, there must have a false, and then I can get a true. So this number 4 is a false. So for 5, it's also a true. And let's say 6 for 6, and this 4 is a false. So 6 is also a true. And let's go to 7. For 7, let's check 4, 5, and 6. So there is a false. So 7 must be true. Now let's go to 8. So for this number 8, for 5, 6, and 7, they always be true. So this means I cannot get a false. So this means for this number 8, it must be a false. Yeah. So this means we can do this problem by the mass deduction. And we cannot use dp because this number n is 2 to the power of 31 minus 1. It's a very big number. We cannot use dp. Yeah. But we can use the mass deduction to get the result, because as we can get the result, if this number is modular 4 equal to 0, if this n modular 4 equal to 0, it means it must be a false, except that it always be true. As you can see that this is 8 and this is 4, and if this n modular 4 equals to if this equals to 0, so it must be a false, otherwise it's gonna be true. Yeah. Now let's just finish the coding. Actually, it is just one line of code. Yeah, so we can just return if this modular 4 should not equal to 0. Yeah, this means if it is not equal to 0, it must be a true. If it is equal to 0, I will lose, so it's a false. It's a false. Yeah, now let me submit it and to check if it works. Yeah, as you can see, it works. So while I'm solving this problem, first of all, I'm thinking about the DP and game theory, and then I checked this n number is very big. Maybe there's some math calculations from the deduction, and then I found the math deduction. Actually, it is this formula. Thank you for watching. See you next time.